Okay, so this is our trig review for the exam. A lot of this material we'll cover in class. This would be good to review at home. First thing we need to talk about is the definitions of the trig functions, and I'm going to start with the cosine, the sine, and the tangent functions. And we'll deal with the reciprocals, secant, cosecant, and cotangent in another video. Now, the definitions, there's three different viewpoints you could look at. The first viewpoint would be on right triangles. Right triangles. Unfortunately, this particular way of looking at the functions restricts the angle to an acute angle. Angle must be acute, but that's not a bad way to start the whole definition of the cosine, sine, and tangent functions. So here's the ideal. I'll draw a right triangle with an acute angle theta, and then I label the three sides. The side opposite the angle we'll call the opposite side. The hypotenuse, which is across from the right triangle, we'll always call the hypotenuse. And the side of the right triangle that is adjacent to theta we'll call the adjacent side. And then by definition, we will define the cosine of the angle theta, always abbreviated cos, C-O-S, theta. You'll never use the six letters C-O-S-I-N-E, but rather cos theta will be by definition the opposite side, the adjacent side. Let me grab my green pen here. The adjacent side, that is the length of that, divided by the hypotenuse. Okay, so by definition, we want that. Likewise, the sine of theta, again, let me write S-I-N-E, but realize this is always abbreviated S-I-N, and don't say sin. It's read the sine of theta will, by definition, be the opposite side, the red one over there, divided by the hypotenuse. And lastly, the tangent of our angle, the tangent of theta, which is abbreviated T-A-N, theta. So tan theta, by definition, will be the opposite side divided by the adjacent side divided by the adjacent side. Okay, so a couple of quick examples might be useful. So if we have a 3, 4, 5 triangle, 3, 4, 5 right triangle, and we have an acute angle theta down here in the lower left-hand corner, we can talk about the cosine of theta being the adjacent divided by the hypotenuse, 4/5. The sine of theta would be the opposite side divided by the hypotenuse, which is 3/5. And the tangent of theta would be the opposite side, 3, divided by the adjacent side, 4. Okay, and that will work for any right triangle where you're given the three sides. You can obviously come up with these ratios. Interestingly enough, you don't need to be given three sides. You know from geometry, if we have a right triangle and we only have two sides, let's say this is 2 and 5, we can easily come up with the third side by using Pythagoras. So this third side, call it C just for a minute. Let's throw a C in there. C. We know that C is going to be the square root of 5 squared plus 2 squared, square root of 29. If we then identify one of the acute angles, let's put the angle up here at the top this time. This is theta. We still have the three trig functions defined: the cosine of theta, and the sine of theta, and the tangent of theta. You do have to be a little careful in this case because cosine is adjacent over hypotenuse. This side now is the adjacent side, 5 over root 29. The sine is the opposite side, which is now 2. Notice 2 is opposite the angle. So 2 over the square root of 29. And the tangent is opposite over adjacent. So that would be 2/5. Okay. And lastly, don't get too confused if the triangle doesn't have the right angle down in the corner. So you can obviously, let me grab a black pen here. You can obviously have a right triangle like this. There's the right angle. Either one of these two could be the acute angle. I'll put the acute angle over here. And I can be given any two sides. Let's say this is 10 and this is 7. And you should be able to, in this picture now, write down the cosine of theta and the sine of theta and the tangent of theta. Okay. In all of these cases, the first thing you have to do is you have to find the missing side. So use Pythagoras to do this. I'll call this side A. And we know 7 squared plus A squared is 10 squared. So A squared is 100, take away 49. So A squared is 51. A is the square root of 51. So sure enough, you can fill in these trig ratios. A is the square root of 51. And now cosine is adjacent over hypotenuse. The hypotenuse is obviously 10. The adjacent side now is going to be 7. So 7 over 10. The sine is the opposite side, so you're going to go all the way opposite theta. That would be square root of 51 over the hypotenuse. And the tangent is opposite square root of 51 over adjacent 7. Okay, so there's your right triangle trig definitions and a handful of examples that you can play with that. Okay, now let's go ahead and stop this piece right here. I will go ahead and pull up the, stop that right there. And we'll do the circle definitions in the second video.